Welcome everybody. We are given this question: x cubed negative y cubed is equal to x negative y raised to the power of 2. We are expected to solve, but with the condition that x and y are integers. So this is the most important condition for solving this question. Now we know this identity, which is a cubed negative b cubed is equal to a negative b times a squared plus ab plus b squared. So therefore x cubed negative y cubed can be rewritten as x negative y times x squared positive xy positive y squared. So if I were to take this as 1, I can rewrite 1 as x negative y times x squared positive xy positive y squared. And over here I can utilize this formula, which is x negative, okay, so I can rewrite this as x negative y times x negative y. Okay, so we can move this to the left, and that would give us x negative y times x squared positive xy positive y squared negative x negative y times x negative y is equal to 0. Now I can take x negative y out and I will get x squared positive xy positive y squared, and that is followed by negative of x negative y is equal to 0. Now from algebra, if ab is equal to 0, this means a is equal to 0 or b is equal to 0. So we have two cases. Case 1, x negative y is equal to 0, which means x is equal to y. So that means if x is equal to, say, some p element of z, y will also be equal to the same p element of z. Okay, so therefore if I were to take, say, p comma p element of z, then instead of saying therefore, I can just say this implies all, okay, all p comma p element of z will be a solution to 1. Okay, so what is the check here? If you are taking, say, some integer, say x is equal to 2, you have to take the same value for y also. So x is equal to 2, y is equal to 2 will be a solution, okay, to 1. So just substitute that value. So 2 cubed negative of 2 cubed would be equal to 2 minus 2 raised to the power of 2. So this in turn means 0 is equal to 0. So that means left hand side is equal to right hand side. So this is acting as a trivial solution. I would say when I say 2, it doesn't mean 2. I'm talking about x is equal to y. Okay. So that is the first part. Now the second part is you have this. So this is the next case. Case 2 also we have x squared positive xy positive y squared negative x positive y is equal to 0. So this means I club these two together. I get x squared x of y negative 1 positive, these two components can be clubbed together. So it's going to be y squared positive y is equal to 0. Okay, so now we will have to consider this as a quadratic. This is a quadratic equation in x. So we will have to solve it. Now let me go up here and write the system. So we have now x squared positive y negative 1 times x positive y squared positive y is equal to 0. This is what we have got. Okay, you see here? Now taking a is equal to 1, b is equal to y negative 1 and c is equal to y squared positive y, and utilizing the quadratic formula, x is equal to negative b plus or minus root of b squared negative 4ac divided by 2a, we get negative of y negative 1 plus or minus root of y negative 1 the whole squared negative 4 times a times c is y squared positive y divided by 2 times of a, that's 1. So this is negative of y negative 1 plus or minus root of, you expand this, you get y squared negative 2y positive 1 and 4 times y squared and negative 4 times y divided by 2. Now this is plus or minus root of, you have negative 3y squared there and negative 4y, negative 2y, negative 6y, and you have plus 1. So you have clubbed these two together, and you retain this one. So this is equal to negative of y negative 1 divided by 2. And you have x on the left hand side. Now the condition here is we need to have x to be an integer. Okay. So if you want to have x to be an integer, this quantity, the discriminant, should be a perfect square. For x to be an integer, because that is what is stated in the question, right? The discriminant should be, I think, should be a perfect square. So this means negative of 3y squared negative 6y positive 1 should be equal to some k squared. Okay. Now I want to rewrite this in this following fashion. I want to rewrite this as 4 negative 3 times of y positive 1 the whole squared is equal to k squared. Now you expand this. Let me expand this and show you. 4 negative, expand this, you get 3y squared and then 2y, it's going to be 6y negative 3. So you are getting 3y squared negative 6y positive 1. Okay. Now you may be wondering why did I do this. I'll give you the reason. Now clearly k squared is a perfect square, right? So this means k squared is greater than or equal to 0. Now this in turn means 4 negative 3 times of y positive 1 the whole squared is greater than or equal to 0. So this in turn means 4 is greater than or equal to 3 times of y positive 1 the whole squared. This means 4 over 3 is greater than or equal to y positive 1 the whole squared. So I'm going to write this as y positive 1 the whole squared is less than or equal to 4 over 3. Now this statement or this system is true only for a certain set of values. Now if y positive 1 is equal to 0, then this system is true. Now if y positive 1 is equal to negative 1, right, if you substitute negative 1, then is the system true? So if you substitute negative 1, clearly the system is true. Now if I substitute y positive 1 is equal to 1, is the system true? 1 squared is less than or equal to 4 over 3, right? So it is also true again. So having given you this, Say for example, if we substitute y positive 1 is equal to 2, is the system true? No. You get 4, right? 2 squared, you substitute there, you get 4. 4 is not less than equal to 4 over 3. Now if you substitute y positive 1 is equal to negative 2, is it true? No. No. 3, substitute 3, no. So none of the values will hold good here. Only these are the set of the values that will be holding good. Okay, so given this information, if I take, if y positive 1 is equal to 0, this means y is equal to negative 1. Okay, so this is the first case. So if y is equal to negative 1, you go up here and find the values for x. Okay, so that is the idea there. So let me go and find the values of y is equal to negative 1. I substitute negative 1, what do I get? Negative 1 I substitute, I get 3, right? I get a 6 here, I get a 1 here. So 3 added, or negative 3 added with 6 would give me 3, 3 added with 1 will give me 4, so root of 4 will give me 2. So I get a 2 here, okay. So x is equal to, write this down. So x is equal to negative, y is equal to negative 1. Negative 1, I get a 2 there, so it's going to be positive 2. This is one set. The other set is negative 1, negative 1, negative 2 divided by 2. So this is going to give me negative 2, positive 2, positive 2 divided by 2, 4 over 2, which is equal to 2. So when y is equal to negative 1, you have 2 there. That's one set. The next set, negative 1, negative 1, negative 2, positive 2, negative 2, 2 is equal to 0. So this is 0, negative 1. So this is the first set of solutions. Now next is case 2. If y positive 1 is equal to negative 1, this means y is equal to negative 1, negative 1, which means y is equal to negative 2. So we will have to get negative 2, y is equal to negative 2, right? So we will have to calculate the value of negative 2. So negative 2 comes here, means it's going to be 4. 4 times 3 is 12. So negative 12 and negative 2, that means you're getting a positive 12 and you get a 1. So 1 is the outcome. So for y is equal to negative 2, you have two set of values you got for x. So x is equal to, let me write that, x is equal to negative 2, negative 1, positive 1 divided by 2, and x is equal to negative 2, negative 1, negative 1 divided by 2, or y is equal to 2. So this is going to be negative 3, positive 3, positive 1 divided by 2, which is equal to 2, and negative 3, positive 3, negative 1 divided by 2, which is 2 over 2 is equal to 1. So x is equal to 1, y is equal to 2, x is equal to 2, y is equal to negative 2. So that's the second system. So this is already done. Excuse me. So let me go to the next one. So y positive 1 is equal to 0, y positive 1 is equal to negative 1, y positive 1 is equal to 1. This means y is equal to 1, negative 1, which means y is equal to 0. Now if y is equal to 0, what happens to the system? 0, 0, 1. Right, so we get the following values. X is equal to, y is equal to 0. You're going to get a 1 there. So it's going to be negative 0, negative 1, positive 1 divided by 2, and x is equal to negative 0, negative 1, negative 1 divided by 2. So this will give you negative, positive 1 and followed by a 1. So 2 over 2 is equal to 1. So when x, or I will say when y is 0, x is 1 there, and in this case you're getting a positive 1, negative 1. 0 divided by 2 is equal to 0. So 0 and 0 when x, or I will say when y is equal to 0, x is equal to 0. So these are the solutions. So what I can do is I can write down these solutions. So let me write down these solutions and give you the output. Okay. So we can start with the following. So let me write the first one, 0, 0, and then you have 1, 0, and then I will write this one, 1, minus 2, and then 2, minus 2, and then 2, minus 1, this one. Okay, and you have 0, minus 1. So these are the list of solutions. Okay, plus for any p element of C, okay, such that you have p, p are all the solutions to the given system. Okay, so that is the conclusion. This is 1, negative 2. And please like, share and subscribe. Thank you everybody.